All right, let's take a look at example 7E. Okay, so we are still multiplying two matrices together. Here are our two matrices. If you notice, the first matrix is the 2 by 2 identity matrix, and then we have this other matrix. So we're going to go ahead and multiply them together. We have to check to make sure that we can. The identity matrix, like I said, is a 2 by 2 matrix. And then this other matrix has 2 rows and 3 columns. So this is a 2 by 3 matrix. Okay, so remember, in order to check if you can multiply these guys together, you need to look at the inner numbers and make sure that they match, and they do. So that means you can multiply these guys together. And then if you look at the outer numbers, that will give you the dimensions of what the result is going to be. Okay, so the resulting matrix that we're going to get from multiplication is going to be a 2 by 3 matrix. Okay, so the result is, or will be, 2 by 3. Okay, so we're going to map out a 2 by 3 matrix. Okay, so let's plan for something with 2 rows and 3 columns. So we'll make it look like this. Okay, this really helps in the process to map it out. Okay, you don't lose your place. Okay, it helps you not lose your place if you do it this way. Okay, all right, so let's start filling in our resulting matrix. Okay, so in our resulting matrix, okay, this is the first row, first column. So you're going to do the dot product of the first row, first column. Okay, so remember to do dot product. You're going to multiply corresponding entries together and then add up all the results. Okay, so we're going to do 1 times 1 plus 0 times 7. Okay, so we're going to get 1 times 1 plus 0 times 7. Okay, so that's what goes there. Okay. All right, so then moving on, okay, I'm going to move on to this element. Okay, this entry is located in the first row, second column. Okay, so now I'm doing the dot product of the first row, and I'm going to change my column to be the second column. Okay, so this is going to be 1 times 4 plus 0 times 3, negative 3. Okay, so 1 times 4 plus 0 times negative 3. Okay, all right, next, first row, third column. Okay, so now you're doing the dot product of still the first row, but now the third column. Okay, so we're going to get 1 times negative 2 plus 0 times 5. So 1 times negative 2 plus 0 times 5. Okay, so that first row is complete. Okay, so now let's move on and let's look at this position. This is the second row, first column. Okay, so now we've got to do the dot product, and I'll go ahead and erase all these little pencil marks here. Now we're doing the second row, first column. Okay, so it's going to be 0 times 1 plus 1 times 7. Okay, and then next is going to be the second row, second column. Okay, so it's going to be the dot product of the second row, and then we're going to change to the second column. Okay, so we're going to do 0 times 4 plus 1 times negative 3. All right, and then the last spot in our matrix is this is the second row, third column. Okay, so you're going to do the dot product of the second row, and we need to change to the third column. Okay, so it's going to be 0 times negative 2 plus 1 times 5. Okay, so 0 times negative 2 plus 1 times 5. Okay, so there you go. Now we need to just simplify. Okay, all right, so let's simplify our numbers here. Okay, this is going to be 1 plus 0, so you're going to get a 1 in this position. Okay, 4 plus 0 is going to give us 4. Negative 2 plus 0. 0 plus 7. 0 plus negative 3. And 0 plus 5. Okay, here is our resulting matrix, okay, from doing the multiplication. Okay. Now, if you take a look at what we got and what we started with, okay, you got this matrix back. Okay. We took this matrix right here and we multiplied it by the identity matrix. Okay. And we got the matrix back. Okay. Kind of the original matrix. Okay. So this is a property. If you take a matrix and you multiply it by an identity matrix of the appropriate size, meaning the multiplication is defined, okay? So if you are able to multiply a matrix by an appropriate identity matrix, you are going to get that matrix back, okay? That is another property of the identity matrix, okay? If you read this bullet down here, the second bullet, okay, multiplication by an identity matrix of the proper size does not change the matrix, okay? That is writing I for an identity matrix of the appropriate size we have for any matrix A. The identity times A is going to return the matrix A. Or if we did, remember, matrix multiplication is not commutative, meaning that the order matters, okay? So if you could do the opposite order, if you did A times the identity, you would get the A matrix back, okay? So these are two important properties of matrix multiplication, okay? Again, I cannot emphasize enough this whole commutative property. Matrix multiplication is not commutative. In general, A times B is not going to give you the same thing as B times A. Order matters with matrix multiplication, okay? And then lastly, if you are able to multiply a matrix by an identity matrix, the matrix will be returned to you. It leaves it, the multiplication by the identity leaves that matrix unchanged, okay? All right, so we're going to do another example, okay? We're going to move on to example 8, okay? And example 8 is just going to kind of put everything together that we've learned in this section, okay? So you're not going to learn anything new. It's just going to be more practice of doing the various operations with matrices. We are given 4 matrices, A, B, C, and D, okay? And the example 8 says, refer to the following matrices and perform the indicated operations if possible, okay? So you can see in part A, we're going to do B transpose minus identity in parentheses times the matrix A. In part B, we're going to do C squared. And then in part D, which is on another page, we're going to do -1 times D times B plus 3 times C times D. Okay, so we're kind of putting all these operations together, okay? So you have various things going on. You could have addition, you could have subtraction, you could have multiplication. Notice we have not mentioned any such thing as division for matrices. We're going to talk about that when we get to 4.5, okay? So you could have all these operations together. So the question is, what do you do first? And the top bullet reminds you that, you know, just like in normal algebra, even without matrices, you're going to follow the usual order of operations. Okay, so you're going to do PEMDAS. Okay, so parentheses, then exponents, then multiplication and division from left to right, and then addition and subtraction from left to right. Okay, all right, so again, we don't really have division of matrices, so I'm going to kind of cross that out. Okay, so again, P is parentheses. Make sure you understand this or remember this. Okay, E is exponents. Okay, and then you do multiplication, and then you do addition and subtraction from left to right. Meaning, say you had, I don't know, I'll make it up over here. So something totally different. So say you had A minus B plus C. Okay, and all of this was defined. Okay, you do addition and subtraction from left to right. So it's like, okay, so I'm going to do the subtraction first because I encounter that first. So I would do A minus B, get that result, and then add C. Okay, it is incorrect in the order of operations to do all the addition first and then to come back and do all the subtraction. Okay, that's not how it works. You do the addition and the subtraction together from left to right. Okay, so again, you follow the order of operations when you're doing these complicated operations on matrices. All right, so here's the first one. Okay, we're going to do in parentheses B transpose minus I all times A. Okay, so the first thing you need to do is write all this stuff down. Okay, we're going to work inside the parentheses first. Okay, so I'm going to go over here and I'm going to write down B transpose minus I. Okay, remember, there is no I matrix up here. Okay, anytime you see the letter I with matrices, that is referring to the identity matrix. Okay, you have to use the appropriate size. Okay, you're not going to be told whether you need the 2 by 2 or the 3 by 3 or the 4 by 4 and so on. Okay, it depends on the situation. Okay, so let's start with what's in parentheses, figure that out, and then we'll be able to do the multiplication with A. Okay, so I'm going to go ahead and write this down. Okay, I am going to go ahead and form B transpose. Remember what transpose means. Okay, every row becomes a column. So I'm going to go to the matrix B. Okay, the first row, negative 3, 1, is going to become the first column. And then the second row is going to become the second column. Okay, so this is B transpose. Okay, and then I need to subtract the identity matrix. Okay, so remember the rule for subtraction. You can only subtract matrices that are the same size. Okay, so since B transpose is a 2 by 2 matrix, you're going to need the 2 by 2 identity matrix. Okay, so that's that part. Okay, we're going to go ahead and perform the subtraction, and that's going to give us what's in parentheses. Okay, so remember to subtract matrices, you are going to subtract corresponding elements. Okay, so negative 3 minus 1 is going to give us negative 4. 2 minus 0 is going to give us 2. And then 1 minus 0 is going to give us 1. And then 5 minus 1 is going to give us 4. Okay, so this is the quantity B transpose minus I. Okay, and I'll even write that right here. Okay, this is B transpose minus I. Okay, so we need to take that result, that's the quantity in parentheses, and now we need to multiply it by A. Okay, be careful. Matrix multiplication, the order matters. So what goes on the left? B transpose I. Okay, so I'm good, or sorry, B transpose minus identity. Okay, so this is going to be B transpose minus identity. I'm going to write that down on the left. And then on the right, I'm going to multiply by A. Okay, so A is this matrix. Okay, so this is how you set it up. Okay, so now we're going to actually perform the multiplication. Okay, so let's check to see if we can do this. Okay, this is a 2 by 2. Okay, this is a 2 by 3. Okay, check the inner numbers to make sure that you can multiply. Okay, they match. We're good. Okay, the result will be a 2 by 3. Okay, so the result is 2 by 3. Okay, so we are going to plan for, we're going to map out a 2 by 3 matrix. Okay, so we need something with 2 rows and 3 columns. All right, I'm not very good at judging how much size I need here. Okay, so let's try to write this out. All right, this first spot in our matrix is going to be first row, first column. Okay, so you're going to do the dot product of the first row, first column. Okay, so it's going to be negative 4 times 2 plus 2 times 0. So negative 4 times 2 plus 2 times 0. Okay, all right, next position. First row, second column. Okay, so you need to do the dot product of the first row, change to the second column. Okay, So this is going to be negative 4 times negative 1 plus 2 times 4. So negative 4 times negative 1 plus 2 times 4. Okay? All right. Then to complete the first row, this is going to be the first row, third column. Okay? So you do the dot product of the first row and now change to the third column. Okay? So we're going to do negative 4 times 3 plus 2 times negative 2. Okay, so negative 4 times 3 plus 2 times negative 2. Okay, so I fit it in there. All right, so let's work on the second row. Okay, so for this position, this is the second row, first column. Okay, so when I do my dot product, okay, we're going to have to do the second row, first column. Okay, so 1 times 2 plus 4 times 0. Okay, all right, moving on to the second row, second column. Okay, so now we're doing the dot product of the second row, second column. Okay, so 1 times negative 1 plus 4 times 4. All right, one more spot. Okay, so this is going to be the second row, third column. Okay, so you're going to do the dot product of the second row, third column. Okay, so it's going to be 1 times 3 plus 4 times negative 2. All right, so now we just need to simplify and we will have our answer. Okay, so I'm going to write the answer over here. Okay, so again, it's going to be a 2 by 3. Okay, so let's just simplify these numbers. Negative 8 plus 0 is going to be negative 8. And then negative 4 times negative 1 is positive 4 plus 8 is going to be 12. And then negative 12 minus 4 is negative 16. And then 2 plus 0 is 2. And then negative 1 plus 16 is going to be 15. And then lastly, 3 minus 8 is negative 5. Okay, so here is your final answer. Okay, this is the new matrix, B transpose minus the identity, all times the matrix